Today, let's talk about top K problems or top K design. There are different use cases for top K design, top K um, system or something. So, top K for what? We can clarify that with the interviewer. Uh, so, the first step will be clarify the scope. For example, it could be top K, so products, right? Um, for m time or like we can configure that like month or year or day, etc. Could be top viewed posts for last day, etc. Or could be like top training topic for example for Twitter may have or TikTok may have like the hashtag. That's also like top K problem, top training. So the that's the scope we want to clarify with the interviewer, and then after that, we will start to deal with the requirements. We will still have the functional requirements. For example, mostly two, I would say two sets of requirements here. One is the CRUD of the create, read, update, delete the either the posts, the hashtag, or the products or the order, etc. So that's one of the main API. The other thing is the GET, the top K. That's like the mostly HTTP, HTTP REST API. You can talk about that a little bit. You can talk about the inputs, outputs, mostly JSON format response. For the functional requirements, yeah. And then the non-functional requirements. So we may have the scalability, that's all the distributed system need to support. High availability, for example, 39049s. High performance for the GET top K endpoint, and we may not have the high performance requirement for the CRUD. But for that, we may want to have the eventual consistency, etc. We can talk about that. Here is we also want to talk about accuracy. For example, the top K it may not need 100% accurate. So which means like it's for some data like especially for the real time, right? So we may have like the real time readouts. We want to show the real time readouts. So for the real time part, like it no need to be 100% accurate. Maybe some duplicate data, maybe like missing data is fine, as long as like they do not impact the final results that much. After the requirements, we will talk about the data estimation, storage estimation. So normally we'll start with a SQL or relational database for structured and relational data. So for example, we may have order, we may have product, and in the order we have product ID, so that's like the foreign key to the product table, etc. User table for sure, etc. So we will talk about that, like all the different tables, like user or account table. We have different like maybe order table, product table, post table, etc. And then we may also have the NoSQL store, data store. For example, for the cache layer, caching layer, for read performance, right? We can talk about that now, or we can talk about it later after the high level design. For now, very high level, you may want to store, for example, the hashtag with key could be the hashtag, and then the value could be number of the training numbers, etc. So this could be one of them. You can also have like maybe products, and for top K, you may have the a time period. For example, the months, and then you may have the a list of products, product IDs here. Top K product IDs. So we can give a very high level of the data storage estimation using some like ballpark number. And then we will talk about the high level design. So for the high level design, let's take a look at the functional requirements. So there will be like mostly two sets of API. We already actually talked about that. CRUD, get, top K. We can quickly talk about that. Like for the API, the input, output, very high level. Then let's draw the diagram. I would say for this type of problems, there are two main approaches. The first approach will be the Lambda architecture. So for the Lambda architecture, let me quickly draw that. So firstly, let's assume we have all the raw data somewhere in a database, HDFS, S3. So somewhere we have the raw data, and then we will have the our batch job. It's like batch job to load the data and roll up to different time period. For example, the batch job will run that, and then we'll roll up. We have a roll up job here. Roll up job. So the batch job could do map reducing, etc. And then the roll up job could roll up to like let's say maybe hour. We also have the day, and we also have the months. We could also have the year. So the roll up job will just roll up all of this data and the year. That's the batch job. Then meanwhile, we may have the real-time data coming in, like maybe Kafka. They have like Kafka, the events in the Kafka topic, and we will have a stream job here. Streaming job. And the streaming job will, let's move here a little bit, consume the events in real time and update to the let's say the fast table just for the latest records, latest data. Already also aggregated for sure. So for example, the last 10 minutes, last half hour. So we'll use our fast table. And then if we already have the rolled up hour for the last hour, so we can add the fast table data on top of that, on top of the day, on top of the month and year, etc. to get the final, together like the final show for the top K based on the user's query. So that's like the where we prepare for the data. And then on the dashboard side, let's say we have the UI, we have the dashboard, and then we have the load balancer for sure. And then we have the application server. So the application server will load from both the like roll up data like for hour, day, etc. Also like depend on what query you are querying, and also load from the fast table to get the real-time data and then show up to the user. And for here, definitely we have more common service with other like services we didn't mention here. For example, the role-based access control to make sure user had the enough permission, access control, rate limiting, etc. And also very common monitoring, logging, monitoring, alerting for all of them, all the system. So like we have monitoring, we have logging, we'll log the status. We will have alerting about both of the jobs if they fail, etc. Alerting. Very common services. And then we have this or call this service and also check the rate limiting. So that's a very high level design Lambda architecture for the top K problems, top K like products, top K posts. On a very high level, I think I want to mention that the key, something to keep in mind is the command query responsibility segregation. Command means like the writing part. Query is the reading part. And responsibility is like their responsibility like correspondingly, and segregation is like, okay, now we have, for example, here we have on the left part is writing, on the right on the right part is the reading. So they have different, we have different services, we have different scaling or performance requirements for both. Okay, so that's the first option for the Lambda architecture. So the second one I want to share here is a more real-time approach for like social media, Twitter, etc. Especially for the training. Is the sharded counter. It's actually not only in this use case. It's widely used for other high writing counters. So what does that mean? So for example, here we have the events. We have all the events comes into the so Kafka, and then we will have like a lot of events. So we have different shards here to process these different partitions. This is like large volume of the data, or on the posts, right? So it could be millions every minute. So we have different shard, like shard 1, we have different like shard 2, different like shard3 components or services to process the events. So here maybe like let's say trending posts. So we have all the like posts with the hashtag, and then we process here, and then we process that. For each shard, it will count the number of the hashtag they saw. For example, here in the shard 1, the hashtag like very popular recently is the TikTok refugee. For that hashtag, for example, here we may have 100 for the shard 1, and for the shard 2 posts, we may saw like, okay, 500. And for the third shard, we may saw just 10. So that's like we have other hashtag as well. We'll count them, keep that in memory. So a little bit deep into this, it depends on the language you are using. For example, if for let's say for Golang, we'll go with Golang as an example here. Oh, Golang. So let's use Go as an example. For Go, we have the Go routines. So for each Go routine, here it will for the shard. It's a little dive deep into this, but okay, I can quickly talk about that since we may not talk about the detailed design for both approach. So for a shard, we may have a Go routine in the shard. Oh, for each shard, this is the inner shard. So we may have a Go routine, and it will process the event, and then it will get the data, for example, TikTok refuge or other hashtag, and then it will output that into the channel. This is like supported by Go, so put that into the channel, and then another Go routine can just consume that all the events from the channel. We have different Go routine, can consume that from the channel, and for 1 minute, and then it will output the data to maybe another Kafka queue, like out of the system, out of the pod, right? So it's a Kafka, but for here it's already like pre-aggregated every minute. So like let's say yes, real time, but minute level. So here we will have the data. We'll save a lot of data. We'll save a lot of the we don't need to log all the raw events. Here is like 1 minute interval. So like every minute we output that. So you have the count, like okay, for the last minute, you have 100 for the TikTok refuge hashtag. Actually, it's no need to be 1 minute, 10 seconds, etc. It really depends on the system or the requirements. So you get that, and then you have the consumer here. It could be a different service to aggregate all the events here from the Kafka topic. Let's say this may be one Kafka topic shared by all the shard. So I just have one consumer from the Kafka topic, and then output, do some aggregation based on the time period, and also based on the hashtag key, and output to a database or non-SQL database, here a key value store. So in the key value store, you will have the time period, and you have the hashtag. And now, very similar to the first approach, now you have the UI. No need to be a dashboard. It could be a UI to load the top trending, and then you have the load balancer separated reading here, load balancer, etc. Relimiting role based access control, etc. Very similar. And then the application server here will load the data from the key value store and show to the user. So and then the application server may do some aggregation based on the user requirements. But like I said, the Kiwi store, we may expire some very old data. For example, the trending for the last year or at some time period. However, the expire, I mean, we may keep the data and just like periodically dump to somewhere, a long-term storage, maybe S3 somewhere, and then we can revisit it later. So for example, if very old and the very long time ago data, if the user is still interested, we can just show that. So that's the second approach. You can see the big difference for both approach. So firstly, the Lambda architecture, it has like the different jobs, streaming job, batch job. For batch job, we can use EMR, MapReduce. We can share like what MapReduce mean and how MapReduce works to the interviewer. For the streaming, we can quickly talk about like Spark streaming vs like Flink streaming. That's like the detailed design. Like for example, Spark streaming may have the latency maybe not as good as Flink streaming. Also for Spark streaming, it's like batch based, like micro batch. But for Flink streaming, it's real like event by event, real time processing. Also, Flink streaming doing much better on the window, like the watermark of the window. They can configure a very long, maybe hour window for the event. But the Flink streaming may take longer or long like learning curve to learn. There's some like pros and cons for each system design is art. Basically, it's like all trade-off here and there. Sharded counter, as you can see, we save a lot of like resource or effort on the jobs, like streaming jobs or batch jobs. We don't need neither of them, and we just use the microservices for example, Go. And we can just get I would say the data in real time, and it works for like perfectly. I know some large systems already use this approach. Yeah, so that's the design for the top K problems. Hope you enjoy it. Thanks.